Energy is conserved. People often talk about conserving energy when they mean using less energy. For example, you switch off a lamp when you leave the room. In physics, saying that energy is conserved means something different from saying less energy is being used. When we say that energy is conserved, we mean that the total quantity of energy stays the same. This happens when energy is stored, changed, transferred, or even dissipated. Look at the energy diagram for an electric lamp. The energy diagram shows that every time 100 joules of electrical energy is supplied to the lamp, 10 joules of this is changed to light energy and 90 joules is changed to thermal energy. The light energy is useful and the thermal energy is wasted. The electrical energy is called the energy input and the light and thermal energy together are called the energy output. The total energy input of 100 joules is the same as the total energy output of 10 joules plus 90 joules, factor 100 joules. This shows how energy is conserved in an electric lamp. The energy diagram for the engine in a car has more energy outputs. In the energy diagram for a car engine, the energy input and outputs are shown as percentages. Notice that the energy input is 100% and the total energy output adds up to 100%. Once again, energy is conserved. In these examples, the electric lamp and the car engine are types of system. In physics, a system is something that has been chosen to study, especially in terms of energy changes. The total energy output can never be greater than the total energy input in any type of system. This is because energy cannot be created. Created means to make something, or to bring something into existence. Wasted energy, such as thermal energy, is dissipated. Dissipated means this energy spreads out into the surroundings and becomes less useful. Although this energy is dissipated, it is not destroyed. Destroyed is the opposite of created. Destroyed means to damage something or to end the existence of something. The law of conservation of energy states that energy cannot be created or destroyed, only changed from one form to another. Feeling cold. Imagine you are holding ice. The ice feels cold. It is easy to think that the cold from the ice moves into your hand, but that does not happen. Cold is not a type of energy. Cold means there is less thermal energy. When you hold the ice, thermal energy transfers away from your hand and into the ice. You feel cold because thermal energy has been transferred away from your hands. You can damage your skin by holding ice for too long, as your skin needs the correct quantity of thermal energy to function. When it is colder outside and you open a window, the inside cools down. This is because thermal energy from the hotter inside moves to the colder outside. Dissipation. You met the word dissipation in stage 7. Dissipation is used to describe energy that spreads out and becomes less useful. Thermal energy moves from your hand into ice, colder, hotter. Thermal energy moves from your hotter hands to the colder ice. When thermal energy moves from a hotter place to a colder place, we say that thermal energy has dissipated from the hotter place. The rate or speed of thermal energy transfer increases when the temperature difference between the hot place and the cold place increases. Remember that energy is always conserved, so the thermal energy has not disappeared or been destroyed, it is just spread out and moved to a colder place. Some scientists think that, billions of years in the future, all the thermal energy in the universe will have dissipated. At that time, everything in the universe will be at the same low temperature. This is only a hypothesis.